Okay, last example, example 4. This time we are not dealing with strictly a polynomial. Now we are dealing with a rational inequality. In order to do this, it follows the same general rule that we started with. You have to get one side equal to 0. So usually we're going to keep the rational inequality portion, the x plus 1 over x plus 3, we're going to keep that there. We're going to move the whole number to the left. So let's go ahead and subtract 2 on both sides. This one is a bit more involved overall because we actually have to do some conversions here. In order to get this one, we have to convert 2 into a fraction. We basically need one fraction on the left-hand side. In order to do that, we have to get a common denominator. Well, the only denominator that's there is x plus 3, which means that we have to multiply the 2 by x plus 3 over x plus 3. So we're going to keep the first fraction exactly the same. It has the common denominator. Then I'm going to multiply the 2 by x plus 3 over x plus 3. Now remember, when you do that and you multiply a whole number times a fraction, you only multiply the whole number on the top of the fraction. So we can put the whole number over 1 if that makes it easier. Then you multiply straight across. So on the first one we keep it the same. Haven't done anything with it yet. And on the second one we're going to distribute the 2 through the top. So it's going to be 2x plus 6. And the bottom just stays the same because it gets multiplied times 1. Now we have a common denominator. So now we can go ahead and combine the tops. Now remember, I have a minus sign in between here, so the minus gets distributed to everything on the top. So we're going to have x plus 1 minus 2x minus 6 on top over my common denominator. And then we're going to combine all of our like terms on the top. So it looks like I've got x minus 2x, that's minus x, and then we have a 1 and a minus 6, so that's minus 5, over x plus 3. And we want all that to be greater than or equal to 0. So in this case, we actually do still have 2 boundary points. What you have to do is you have to check what makes the numerator 0. You also have to check what makes the denominator 0. Here is a very important thing though. When you check the denominator, whatever makes the denominator 0 must be eliminated from the domain. What that means in the final solution is there will never be a solid bracket around whatever makes the denominator 0. It's always going to have a parentheses. So just looking at the denominator, hopefully you can see that one of my test points or one of my boundary points is negative 3, right? Because if I take the denominator, x plus 3, and set it equal to 0, we would get x equals negative 3. That one can never be included. But it is a boundary point, so we have to still check around those values. The other boundary point comes from whatever makes the top 0. Okay, so I'm going to go ahead and add 5 to both sides of that. And I'm not solving for negative x, I want positive x, so I have to divide or multiply both sides by negative 1, so we get that x equals negative 5. That one is another boundary point. That one can be included depending on what the original sign was. And our original sign here had an equal to symbol, so that negative 5 could be included in our boundaries, in our solution. So let's go ahead and check our number line. Again, we're going to write these numbers on here numerically. Negative 5 is first, then negative 3. We have 3 sections to check. We're going to have to check here, have to check in there, and we're going to have to check out there. So let's go ahead and take a number which is less than negative 5, like negative 6, and we're going to plug it in. So if we take negative 6, so I've got negative 6 minus 5 over negative 6 plus 3. Let's see. Simplifying that one, negative 6 is positive 6, minus 5 is 1, over negative 6 plus 3 is negative 3. That gives us a negative value. We wanted it to be greater than or equal to 0, so this is gone. We do not want that one. That is not good. That's not a true statement. Okay? Let's see what happens when we plug something in between -5 and -3, which is going to be like -4. So let's go ahead and check -4. So if I plug in a negative, -4 minus 5 over -4 plus 3. Minus minus 4 is +4, but +4 minus 5 is -1 over -1. Well, -1 over -1 is +1. And that is greater than or equal to 0. So that is a good section. And then the last thing I want to check is anything which is greater than -3. I'm going to pick 0. I always pick 0 or 1 if I can. It's just the easiest numbers to use. So if I pick 0, let's scroll this down just a little bit. If we pick 0, plug it in, we're going to get -0 minus 5 over 0 plus 3. And 0 minus 5 is -5 over +3. That is a negative number that is definitely not greater than 0. So that one's bad. I don't want that one. Don't want that one. I did want that one. So I only have one section. My section is in between -5 and -3. Remember how we said that the -3 in this case, because it was in the denominator, cannot be included, so it gets a parentheses. The -5, however, because the original function here did have the equal to symbol, the -5 is included because that was not something in the denominator, so that was okay. So that is the solution to that problem. All right, there are some really good application problems for this. We are not going to cover those at this time. I'll be very happy if we're good with mathematics behind this section.